Minglava. Welcome back to the series of machine learning algorithm using Python. I believe by now you have watched my videos on other classifiers such as supervised machine, logistic regression, and k-nearest neighbor. If you haven't watched, I encourage you to watch these videos. Today, I'm going to start a new classifier called tree-based classifiers. So the first tree-based classifier I want to discuss is called decision trees. So decision tree is a type of supervised machine learning algorithm that uses a series of conditional statements to partition the training data into a subset. Right. So before we go into dive into the decision tree, let's look at a simple example of our daily decision. All right. So this figure is extracted from the internet and then I give the sort here. Okay. So now let's say we are being offered a new job. All right. So now we are thinking whether we should accept it or not. Okay. For this case, uh, I have a three criteria to be considered. Right. So obviously, first one is the feature, the salary, all right. Then the community time between the office and home, and office welfare. So these are the three important criteria I have it to make a decision whether I should accept the job or not. So the first and foremost important feature is the salary. So I will start with the salary. So from the salary, I make a decision. If the salary is more than 50,000, right, then I will make as a yes decision. Otherwise, I will make as a no decision. All right. So it shows by the green color. So I will decline the offer. Okay. So decline the offer, there's add. We don't need to consider anymore. But now we have the yes branch. For the yes branch, I will consider another feature, which is a community time. If the community time is more than an hour, again, there will be yes or no based on the community time if the community time is more than an hour. Right? If it's more than an hour, yes, I will decline the offer. So there's an end branch. But we have that there's no branch, which I need to make another decision. Right? Then I will split the decision again to yes and no based on the office welfare. If office welfare is good, then we go to yes. Otherwise, it goes to no. Right? Even though there's a yes, we don't need to consider anymore. I have or consider all the criteria that I need. Right? So these either accepting the offer or declining the offer here are end note. Right? So in decision tree, those show with the green color are called leaf nodes. They are end node. We don't do the anymore branching. All right. So those which show by the blue colors are called decision nodes. Okay. We make a decisions, all right, based on this particular node. The first node that we take to split the data that is called root node. Right? So decision tree is very easy to understand because it can relate to our daily life. And it doesn't require a lot of data preparation. And one good thing is decision tree can be used for both category and numerical data, as you can see. But in the current implementation of sklearn, we see that they support only on the numerical values. Right? But the problem with the decision tree is, as you can see, if you have a lot of criteria and features to be considered, you need to create a over complex tree. All right. Then what can over complex tree can do? All right. So what will happen? Then that will lead to working only for the data that you have. It's not generalized enough for the new data. Then for the imbalanced data, if you have one particular class is much more than the other class, it will create a bias also. All right. So what is the next solution? Tree-based classifier, which is random forest classifier. Random forest, like its name implies, consists a number of individual trees, right? Individual decision trees. What we do is, given the data set, we first select the random samples from the decision tree. All right, select randomly. Okay, so it could be the whole data set or it could be a portion of the data set. All right, so depending on your parameters that you may use. Okay, so then when you take out the random sample set, and then from this random sample set, you create a decision tree. You build a decision tree for each set. All right, then from each set, you get the result. Okay, then you do the performance bodies. You do the majority body, right? So then, based on the majority body, you select the result with the most vote as a final prediction. Right. So in the given example, you can see from the figure that class 3 1 both for class A, 3 2 and 3 both for class B. So if you take the majority body, you have to select the class B as a final result. All right. So this is how the random forest works. So random forest outperform decision tree. All right, especially for a data set with large number of features. It also overcome the problem of overfitting, right? Then it can also be used to select the more contributing features for the classifiers. But this outperformed random forest classifier also have some drawbacks. One obvious problem is computational complexity and time consuming because you need to build a decision tree for each sample set, and then each decision tree need to make a decision, right? The needs to predict the result. Then you do the majority body. So it can slow in generate you the prediction. All right. Okay. So now let's move on to implementation of random forest. Python implementation of random forest is quite easy. As usual, we import the method from the sklearn ensemble package. And our data is split into training and testing data set, and then we initialize the random forest classifier with a few parameters. Under the sklearn, you can see the parameters, all right, that you can actually define. Okay, there are a few hyperparameters you can fine tune for random forest classifier, or you can use a grid search CP to fine tune these hyperparameters. For example, maximum depth, right? This decide the longest path between the root node and leaf node. You cannot go beyond that. Okay, and maximum samples. Maximum samples determines the size of the set sample set. All right. If bootstrap is true, by default it is true, then the set sample size will be decided by maximum sample. If maximum sample is not given, the whole data set will be used for each decision tree. Then you can use the fit and to build the model using the training data, and then you use a score to predict the accuracy for the testing data. Right? As you can see, implementation in Python using the sklearn is pretty straightforward. Right? But you need to understand the theory and concept behind for tuning the hyperparameters and preparing your data to get to make your model to get the result that what you want. So in summary, random forest classifier is also a supervised learning algorithm that is can be used for both actually both classification and regression problem, right? But in most of the mainly used for the most of the people use for their classification. You can use a regression, all right? So if you use a regression, the performance will be the process will be the same. Just that except of taking the majority body, you can use the average values, right, to get the regression result. That's the only difference. Okay. All right. Then random forest is consists of like multiple decisions tree. All right. So then you get the decision tree from each of them and finally select the best result for the classifier, or you take the average for regressors. Okay. If you have more tree, the program is more robust, perform better. Right. But the performance always come with the drawback. You have the complexity in both computation and time. Right. Okay, that's all about the random forest classifier and decision tree. Next week, I'm going to start about the unsupervised learning method, which is clustering. Thank you. See you all in next video.